look at the formulas, okay, one said cylinder. Which problem number has the cylinder in it? 1. Okay, most of these were fairly simple to identify. Yes? What might have been questionable? I mean, by process of elimination, maybe it was fine, but what if I just put that on there, would you have not maybe been sure? Okay, so LA that shows up in the formula, and which shape was it a little bit like iffy? Like, was there any shapes, or you guys know exactly what all those shape name means? So everybody knows what a right prism is. Okay. All right, so on this page, right prism was which problem number kind of by default? 3, okay? So we'll look at 3. However, a right prism doesn't have to look like that. This is where a right prism is difficult. A right prism just has multiple faces. That's what we call all the sides, okay? And it has 2 of what we call bases associated with it. But most commonly, you probably see, and forgive me because I am not a Miss Hoffman. You guys have Miss Hoffman?
Yeah.
Yeah. Yeah. You know, she has like a degree in art, right? Yeah, she does. She does. Okay, there's my very crooked box. But that could be a right prism also, okay? It's not about like whether there's triangles or squares. There could be hexagons in a right prism, okay? So that one should have been a little iffy because it's not the same as all spheres are shaped the same, right? But that's not true for right prism and kind of not true for pyramid. That can change a little bit too, but a pyramid's more recognizable for us. So just make sure you understand this is the right prism, but it could look differently, okay? And then we had a specific question about the formula, right? Look at the formulas for the right prism. It says for the surface area, 2b plus LA. And the b's are capitalized, all right? Does anybody know what the capital B means? No. You're not wrong, but you're not right, okay? When we want someone to use base of something, we use a lowercase b, and a base is one measurement on an object. So like if I drew a triangle up here, and I said 6 was the base of the triangle, I'd use little b in a formula, and I'd just pull that number out when I wanted to use it, and that would be that, okay? Good. The capital B is actually the area of the base, meaning the base is not a single number because we're not talking about 3-dimensional figures. The base is an entire face, an entire side of the object, okay? Does anybody know then what the LA stands for? So if you have to write it down, capital B, area of base. Yes, sir.
Lateral area.
Good. The LA is lateral area. Do you guys know what lateral generally means? Kind of on the side, when people talk about lateral parts of something, usually on the side. So when you look at a figure, you're saying these parts are the bases. These other parts would all be the lateral area, because if those are kind of the base, like top and bottom, the laterals would go around the side, okay? So look back at your figure here. What is the base? Well, actually before that, how many faces does it have? How many pieces does it take to build that figure that's up there? Oh, look, I just did fun stuff with that. That's not what I wanted to do. There you go. How many pieces or faces does it take to build this figure in number 3? 5, okay? What different shapes do we have involved in this? Rectangles, I would argue, not squares necessarily. I don't think any of them have all 4 sides the same, but okay, rectangles. How many rectangles are being used to make the figure in number 3? 3 rectangles, okay? We have one along the bottom right here, right? And then we have a different one along the side and a different one along that slanted edge, okay? Those are the 3 rectangles. Can you guys see where they're at? Okay. So that's 3 out of the 5 faces that make up this object. What are the other 2? Triangles, okay? So we have 2 triangles and 3 rectangles that put together to make this shape. Fair enough? Okay, which piece of this is the base of the figure? Okay, so he says triangle. Rectangle. All right, we want to say rectangle. How many of you like the blue one that I colored in as the base? Yeah, it's sitting on it. Why wouldn't it be the base? Because you could draw it sitting on any of the sides, okay? So if we draw it another way, does it change what the base is? We can't have that, okay? So the actual definition of a base is one of the sides of the figure, and in a right prism, there has to be another exact one, congruent side. So they have the same size and the same shape, and they're parallel to each other. Do you guys now agree with our suggestion that the triangle is actually the base? Yes, it is the only thing up here that there's another one of the exact same size and dimensions that's parallel to it. So when they say B in your formula, they are actually referring to the area of the triangle, okay? So you have to actually do a lot of work to get the number to plug in for B, right? It's not a number from the picture. It's the area of this triangle. And do you know the side lengths of this triangle? What's one of the side lengths of this triangle? 5, sure. I heard someone else say the other one. 13, it's the hypotenuse, right? To find the area of the triangle, which two sides do we actually want? 5 and the missing one, right? We want the two that are perpendicular to each other. Those are what we would call base and height of the triangle. So you actually have to like find a missing side, then find the area of the triangle, just to know what to plug in for the big B in this formula. Is that okay with everybody? All right, and then what am I going to plug in for the LA of the formula? What did we say is the lateral area? Yeah.
The area of the 3 rectangles.
Good. Do you guys know why he's including all 3 of the rectangles? It's everything that's not the bases. So your bases are your triangles. So those are covered with the B. Everything else is part of your lateral area. So to find lateral area, you actually have to find the area of those 3 rectangles and add them all up together to get the total number that you should put in for lateral area. I know I'm not giving you the answer and I'm not doing all the arithmetic for you, but now when you look at that formula, do you have a better idea of what those things actually mean they want you to plug in, and that you're going to have to go do some work to find them? Okay? Would we have a better start on this problem now than we would have before? Probably would have just plugged in a couple numbers. It would have been quick, right? Now we know it's going to take a little bit longer. Yep. I'm going to leave this at that, and I'm going to walk around and help you guys when you're calculating. Does everybody at least feel at this point they have an approach? They can sit down and start trying to do something to find something to plug in. It might not be perfect. I might get stuck, but I now know what the letters actually mean, and I can approach that idea. Okay? All right, look back at your formulas. Which formula looks a lot like the right prism formula? Uses the same kind of letters and stuff like that. The pyramid. Okay, so I'm gonna look at that one next, because if they're using the same things, they gotta be kind of related in topic. So let's look at the pyramid. And so the pyramid's formula for surface area almost looks exactly the same as the right prism. What's the only difference between their formula? Yeah.
They don't have, the prism doesn't have 2 bases, it only has 1.
Good, and I like that you said it like that. He's not just identifying that the formula is different. He understands the concept of the formula. The right prism had 2 B's in it. It literally had a 2 in front of the B, and this only has 1 because the pyramid does not have 2 bases like our right prism had. The pyramid only has 1. Okay? What's the base of the pyramid? Which shape? The square that is sitting on the bottom, okay? The lateral area pieces all come to a point in the pyramid, and what it's sitting on is actually its base. So this is your base of your pyramid, this 16 by 16 square. So every time we see the B, we're actually want to plug in 16 times 16, the area of that square. Okay? How many pieces in total would it take to build this pyramid? 5, okay? 1 is the base. And what are the other 4? Same shapes, different shapes. Triangles. Same size or different sized triangles? Same size. Kind of nice. That means less work, right? Less different calculations to have to do. So for us, these triangles are making up our lateral area, and our lateral area is specifically made up of 4 of them, okay? So we're going to have like, find the area, add another one, add another one, add another one. The only good news is they're the same size. So once I find one area, I can just keep adding that number together 4 times or multiply it by 4 if I would prefer. Okay? Now the square, it was easy for us to quickly mark 16 by 16 and we kind of know where to get that number. The triangle area takes a little more work, so I want to think about what this triangle looks like, so I'm making it bigger so you guys can see. If I wanted to find the area of this triangle, I would need to do a 1/2 base times height calculation. And so I need a place where the triangle meets in a perpendicular like that. That's why I drew down that altitude, they call it, right? And so I need these 2 numbers. I need this guy, and I need that dashed line that I drew there. Do I know one of the numbers?
Yes.
Yes. What do I know?
The dashed line is 20 inches.
Okay, so let me be real clear. The triangle I'm drawing here is the triangle I've outlined in red. So its dashed line is actually this guy. Do you guys see the difference? They call that like a slant height. So the 20 that you see is like Indiana Jones at the top of the pyramid dropping the rope down to the middle. The red dashed line I just drew that I need for my triangles is like somebody climbing up to the top of the pyramid and sliding down the side of it. All right? Do we see the difference? Are we good with it? Yeah? So it's not 20, okay? And we don't know immediately what it is.
It's 16.
Is it 16? So we do know 16 as a triangle. This part of the triangle is 16. So I can still that measurement and have part of my triangle, 16. But I'm still missing that dashed line there, and I need to figure that out before I can finish just calculating the basic area of this triangle. Right? But that dashed red line I drew does connect to the 20. Do you guys see that? Right here at the tip of the pyramid, my red dashed line would connect to that 20. Okay? Here's the 20 down here. And then I could connect them together. And what would my purpose be there? What have I just created by connecting my red dashed line down the side of the pyramid with that 20 and then connecting them together? Another triangle, and this triangle is actually really special. What kind of triangle is it? A right triangle. So if I pulled that out to look at it, what I have right now is this, with this dashed line being the one that I'm like looking for over there. And right triangles should be super special to us. I know that you guys might not feel the same way I do about all the mathematical objects, but they should be because they have so many things about them we know, right? Trig, right triangle trig, all your SOHCAHTOA stuff works with right triangles. And what else? What big theorem works with right triangles? Pythagorean theorem, right? Man, that guy, right? Famous theorem. So we know 20. We know we're looking for this. Do we know the other piece of the triangle? Look at where it came from. It came from right here. Do you know how long that piece is in that diagram? 8. Because if the whole way across the pyramid is 16 and I'm just going from the middle to the edge, it's 8. Okay? And now I could do something like 8 squared plus 20 squared equals x squared, and I could finish solving for that. That's a lot of work, and it's not even the answer to anything. Like that number you're getting is just giving you this right here to plug in your 16 with that number to find a triangle area. And then you need 4 of those just to put in your surface area calculation, okay? So a big deal for you guys is gonna be to not lose track of where you are in the problem. Like, what are you actually doing right now? Are you finding a final answer, or are you finding something to plug into something else and keep going? So just make sure you guys keep good track. Do we feel like with all the capital B's and the LA's, we understand at least what the pieces are and we can get through like the pyramid and the right prism? Is that part okay? All right, on the formulas, now look at your, probably the ones you'll like the most are the cylinder and the sphere. What do you have to plug into any of your formulas for cylinder? R is up there. What does that stand for? Radius. And then what else do we need? Height. Look at the cylinder that's on your paper. What's the radius? 2. And what's the height? 18, because it connects the 2 circles together. Okay? What do you need to do a calculation for a sphere? What's the only piece of information you need to know about the sphere? Radius. Okay? And we can plug those in. So I think you guys will be pretty set in that area. And then I just want to address, look really closely at the cone formula. What is in that formula that you have not seen yet and could be bothersome? Oh, you even knew what it was called. Okay, right here, there is an L, okay? This L actually stands for slant height. So you know how we were just basically talking about the slanted height in the pyramid? I just didn't give it another letter, but they actually do, okay, when you look at the cone. So when we look down at your cone, what is 18? What part of the cone is that? The height, the H height, right? The straight up and down, drop from the bottom to the middle height, okay? So 18 here is the height. The L is actually this part here, okay? That's the L. That's the slant height down the side of the cone. And what's this other piece they have marked in here? Radius. Notice that together your slant height, your height, and your radius make that right triangle again. Can we use Pythagorean theorem again? We could, but if we set it up, it would say 18 squared plus r squared equals L squared. Can you guys solve that?
No.
No. Okay. What can you do here? Does anyone know? You might feel a little sad about it, not gonna lie. Yeah. Yep. All right, we hear SOHCAHTOA, trigonometry. Okay, maybe I'll tell you guys a story later about why I really don't like SOHCAHTOA. I like trig. I like it. I don't like the way we try to remember it. Don't you guys think it seems a little silly? You don't remember how to spell SOHCAHTOA. It's not a real word, but that's what we chose to remember it by? I don't know. Okay, so I can set up trig, but you all use this, so I'm just going to write it, even though I'm not a giant fan. And these stand for the different trig ratios, right? So like the SOH means that when you take sine of an angle, so if I wanted to take sine of my 66-degree angle, I set that equal to a ratio that has the opposite over the hypotenuse. What's opposite of 66 at this triangle? 18. 18 would be the opposite, the side of the triangle that doesn't touch the angle, okay? 18. And what's the hypotenuse of the little triangle? So we're looking at our triangle here. What's the hypotenuse in this triangle? Hypotenuse is always across from the 90-degree angle. The longest side, it's the L. Okay. Now, that might not be a pretty equation, but is that a solvable equation? Yes, sine of 66 is just a decimal number. If you're not sure, you can type in sine of 66 and change it to a decimal number. And then you can multiply some stuff, divide by some stuff, and eventually figure out what L is. Okay. Once you have what L is as a number, can you find R? Yes. What are your options for finding R? One option is Pythagorean theorem, because now you have enough numbers. And if you really like trig, you could use one of these other trig ratios to set up an equation that uses the R with the 18, and then you can solve it that way as well. Okay? I know this wasn't everything, because I want you to try and get back in the realm of geometry, but was it enough to remind you of all the different nuances, like you do have trig and Pythagorean theorem as a tool, what these letters actually represent, so you're not spending time doing a calculation that's not actually meaningful in the context of what we're asking, okay? All right, any other